Applications. My name is Yaniv Zimet.
And I'm McKenna. And the abstract, if you read it, we're talking about the project and the progress that we've made to date. So we have not completed the project at this point, but we'll be able to talk. A lot of this is going to be about where we are, the decisions that we've made, why we're taking the approach that we're on. And just for your information, there's another session this afternoon done by PayPal, which they are also doing something very similar. So we'll be able to compare notes between different teams, different companies, and what they're doing. So out of curiosity, how many people know what block is, or who block is? Quite a few, actually. So we'll talk a little bit about who we are. So we started as Square, which was a company founded by Jack Dorsey, who, besides Twitter, is also an artist. And he was trying to sell some wares at a flea market. And he figured, I don't have a way to accept credit cards here at this art show to sell some of my wares. So we got together and put together Square, which is the little plug-in Square thing that went on your phone, and to be able to accept credit cards remotely. And that evolved over time. By 2013, they started something called Square Cash, and that became Cash App. And those were the two products, the fintech products that the company had. It was just called Square, the company. But then we started acquiring some other companies. One was Tidal, which is a high-resolution music app specifically designed for music artists. And with that, they happened to get Jay-Z on the board of directors. And from there, they acquired Afterpay, and then they created BitKey, which is a portable Bitcoin wallet, encrypted wallet that you can carry around. And then Proto, which is something that we've come out with, which is a Bitcoin mining system, which includes the hardware that's involved. But the project that we're working on is specifically related to Square. So with Square, what they do, in addition to what you've seen on food truck apps and so on, they do food and beverage. They do appointments, for instance, for beauty or beauty salons, things of that sort. They also take care of various online shopping sites with them. We produce the kiosks that are at the restaurants or pizza places that you go to. We also produce various terminals, point-of-sale terminals, and so on. We're in, today, when I joined, we're in about 8 countries or so, so it's not huge in terms of the global presence that we have. So as started to go into building up the globalization team, looking at why do you do globalization? You're doing it to be able to increase the linguistic quality for the markets that you're in, that you have French versus Canadian French, that you have the terms that you use in different regions are going to vary across the board. You want to be sure that your products are extensible into different markets, that the products that you build are maintainable. You want to reduce the time to market, and you also want to have portability. So Square also builds an API that third-party developers that can connect to. You want to be sure that whatever systems and standards they're using can also connect in through the API itself. So when I started to dive into the repositories. We have code in Java, a lot in Ruby. There's code in JavaScript. There's a lot of C++, that's in place. And one good way to do is to start at the top and you put in some keywords. We're in Japan, so you search for JP. JP is a term that you're not going to find in most other contexts in software unless it's related to Japan. And so that starts to tunnel down into different areas where globalization takes place, and then start looking for specific libraries, how things are handled. And as I started to dig through, found out that there's a number of places where things were actually done pretty well. They're using the standards recommended by Apple or Google for the mobile devices. Some are using ICU. In some other places, it was not so good. The way that the company was set up when I first joined was what I call a studio development model, where each feature team was given as much freedom as possible so that they could develop and be creative and be able to come up with all kinds of ideas and solutions. But as a result of that, there are various solutions that were reinvented multiple times. The wheel was created multiple times. Some teams looked at other teams and got good ideas for internationalization and how to do it. Other teams just built it their own way. There are places where things were configured differently and configured very specifically and brittly and were built in manually when we entered each market. Oh, we're going into Spain. Let's add this onto this file to do this specifically for Spain. So there's a lot of work that needs to be done to build up the whole code base to allow us to enter in easily into multiple markets. So you go, there are things that you can do as software engineering. You can be reactive and I'm going to go fix the bugs. I'm going to correct the translations as they come back on a regular basis. I'm going to do lots of troubleshooting and so on. But what you end up doing oftentimes is you have the customer finds the issue as opposed to you finding the issue before it goes out. So you want to be proactive. You want to prevent the bugs before they go out. You want to establish best practices that are global ready so that the company can move forwards and be able to be on a solid basis for everything that's in place. So block, well, let's do a quick question. So how many of you are working for a company that is having a very strong emphasis, or at a school that is talking about a strong emphasis on using AI as much as possible? So virtually every one of you. Same thing at Block. So at Block, you go, well, let's just use artificial intelligence and say, make global applications. So let's see what happens if you do AI out of the box. So we have a tool that we've built that's open source called Goose, and Goose is basically an agentic vibe coding agent that you can use to then be able to create applications. It goes in, installs the software, does the compiling, everything on your machine to create a new application. So I basically started with a prompt to create an application that has a list of customer names, populate it with common names for the regions that we're in, include the person's name, their locale that they're in, and come back with data, and then reply back to each customer according to your locale that, hello, name, you ordered X items for a cost of certain amount. We'll ship it to your address. That address, if you have any questions, we'll contact you at this phone number. So the goal of that is to look at how the AI will generate handling things like names, dates, amounts, currency, and so on. So it went through and dutifully did its job, and it said, okay, let's set it up. So I said, let's try it. I first did it. It went off its way and did it in Python, and it said, no, let's go back to Java. It says, okay, I'll help you. We'll create a Java version on the order notification program using appropriate Java classes for internationalization. We'll use, and it used all these standard Java classes. Didn't even look for ICU. So that means it'll use what Java provides. So, okay, that'll get us so far, but let's see what it does beyond that. How about plurals? It drops down in, and do you have, I asked in the prompt to handle plurals correctly. So it said, you can have, you ordered one item or multiple items. And in the code, it has, if count equals 1, we'll go ahead and pull the singular form. Otherwise, we'll pull the plural form. So that right off the bat is going to be broken for a number of locales that require more than 2 forms. And this is AI that has done this for us. Then what about date formatting? So one of the regions I asked for is for Japan and Taiwan. It says, okay, well, if it's going to be in Japanese or in Chinese, then we'll use this date format. Otherwise, we'll go ahead and use the date formatter. And just going, well, wait a second. Don't you have a date formatter that you're already calling to do this for? Why are you doing this specifically? So that right away is creating brittle code that's difficult to maintain. And then you go, well, what about the data that it's building up? So out of the box is, okay, we're going to have a part of our data, which is locales. It starts off with the US and drops down in. But then one of the regions I had was for the Czech Republic. So instead of using a standard ISO code, it has the name of the country spelled out, which already is going to be brittle. It's non-standard. It's not going to be portable moving in. And then you see it's got some sloppy build-up slow in the template for hello name, because in the Czech Republic, you have a different term of a dress, whether it's a masculine or feminine, for hair or hair, it uses just a vazenye or vazenya, and then whether it's going to be singular or plural, you have to change the context there. So it should, if it had the knowledge to do that, use something like from the inflection project from yesterday, and then it drops in and gives you a singular and a plural form, which works. The singular and plural works okay for English and for several Latin-based countries, based languages. But for Czech, you've got 3 different forms. So there should be poloska, polosket, and then there's a poloski, which is for the few in between 2, 3, and 4 before you get to 5 units, and then it goes into the other form. So using AI out of the box tells me that AI is going to use standard large language model. So with large language model, it's going to use what is most common that it finds on Stack Overflow and GitHub and so on, which invariably is most often it is statistically wrong. So that told us that, well, we can't use AI out of the box. So what we've seen, it's not using standard region codes. It assumes 1 language per region. When I looked into the way things were set up, sloppy plurals, it didn't do gender handling, embeds formatting and layout with the content, the one huge data file. It's got all the regions in it. Other things I didn't show is poor phone structures that it had. There's no attempt by AI to find or use libraries for phone, address, or even look at ICU. So that told us that in able to use AI in our company, it's going to need a lot of help along the way, lots of hints, a lot of training, and so on. So that leads us to the project that we're looking at. So off to Yaniv.
Thanks, Mike. So let's take a closer look at how we've built some internationalization issue detection so far. We've made a couple different approaches towards detecting issues in source content and also detecting issues in source code. And we've approached these 2 in slightly different ways. We'll also look at how we've embedded these quality checks into workflows so that engineers and product stakeholders can be aware of these issues and have a chance to make improvements. So first, let's look at how we've detected issues in source content. Our goal here is to detect issues before the content enters the translation pipeline. We would like to make sure to have as high quality possible English source content so that the target translations can also be high quality. Nearly all of our content flows through Atlas, which is our internal platform for managing localization workflows. So in this diagram, you can see an example of some of our content that's originating in GitHub, and as it passes through CI, it makes its way to Atlas. So Atlas is a perfect place to do this issue detection before we send it off to the translation vendor. In this approach, we set up rule-based linting using a third-party open source library called iLibLint. We've configured about a dozen or so rules that we detect for, and let's take a look at a few examples. This example is related to a string about order selection. In English, it says, select a order type. An order type here is a variable. And depending on context, that order could be a check, like a check at a restaurant. It could be an order, like an online order. And so depending on what the noun is, it will be interpolated into this string. And translators here are presented with a grammatical challenge. The article must match the noun's gender. But the noun's gender is unknown. It's a variable. So in Spanish, the translator just happened to choose the masculine version of this translation. And if the noun is masculine, like un pedido, then the grammar is correct. But if the noun is feminine, like una cuenta, this is not possible in the way that the translator set up this translation because there wasn't really a way to set up for both. So for now, we consider this an internationalization issue. Here's how this screen looks like for engineers and for product stakeholders when they see the result. They can see that there's a issue type, internationalization issue relating to noun replacement. And highlighted in red, they can see the English source, exactly where the issue is positioned. And the recommendation here would be to use more static strings, or maybe to structure the sentence differently to avoid these grammatical challenges. Let's look at another example. This example is related to plurals, and the cancellation confirmation in English reads, some number of items have been canceled. And it's using the parentheses S syntax, which is kind of a lazy way of doing pluralization. Even though we have the quantity available in the count variable, it's not really being used to differentiate any plural forms. And so again, translators are presented with a grammatical challenge. In this case, the adjective, or past participle used as an adjective, must agree in number with the noun that it modifies. But in the French translation, this would result in two parentheses S constructs being affecting the plural markings in multiple words. And the result looks sloppy. It's not really used in natural language in French. And so we would like to avoid the situation, and we detect an internationalization issue. Again, here's how the result looks like to engineers or product stakeholders. They can see the internationalization issue relating to lazy plurals. And again, highlighted in red is the location where the issue took place in English source. And the recommendation would be to improve this by using real plural syntax. All right, now let's take a look at how we detect issues in source code. So we took a different approach here. Source code is not necessarily content that needs to be translated. It doesn't necessarily flow through Atlas, the system that we mentioned earlier. We have a lot more code than we do content, so it's a much larger data set. And so for this, we've built a custom scanner using static analysis and AI. We detect issues across many different programming languages, like Mike mentioned earlier, including weakly typed languages like Ruby. We're also considering that teams have approached the same problem with multiple solutions, and so there have been many implementations across the codebase that deal with the same concern. Some of those we would like to maintain that are bespoke solutions that work really well, others that we would like to make more consistent and follow other best practices. Let's look at some examples of this. Here's again plurals. And this is a step in the right direction. So this time there are variations between singular and plural forms. However, you can see that there is hard-coded logic about the pluralization rule. In this case, if the count equals exactly 1, then we use the singular version of the string. Otherwise, we use the plural version. And this works fine in English or in other languages that have similar pluralization rules to English. But it's not very scalable if we wanted to expand to other languages that have more complex plural rules. We also don't really want to maintain all this hard-coded logic throughout our code base. So here's the result of the internationalization scanner that came across this code. The issue type is categorized as hard-coded pluralization, and the engineer can see the exact line number and column position where this issue took place, and also the code snippet of what exactly was going on so that they can understand and have an opportunity to correct this. At the moment, we are collecting a lot of information about which issues come up most frequently and which code bases they take place so that we can reach out to teams and help explain and help provide the right support for the right types of issues and prioritize where to spend the most time. Here's a few more examples. Hard-coded date formats. In this example, there's a date format that represents a Japanese date range with a specific separator character. And when formatted, this actually looks correct. However, we, again, don't want to maintain hard-coded date formats in our code. It's brittle. There's a lot of different combinations. We would prefer to use a standardized curated set like is available in CLDR. So we would flag this as an internationalization issue. Another type of issue that we detect is brittle address displays, and specifically country-specific ways of displaying address fields. In the United States, we order our address fields differently than would be ordered in Japan or in other countries. And also, our product teams have been, as they've been implementing their own approaches for this, they've labeled them in their own ways. And so our labeling is also inconsistent. So for example, the labels of street address 1 sometimes are labeled as address 1, sometimes street line 1, and sometimes in the Japanese, chome banchigo. And so we detect anytime there's country-specific logic for displaying addresses so that we can understand how to make this more consistent across our teams. And the third example is old libraries that are still in use. In this case, we see an example of Joda, Joda library in Java, which served great for a very long time, but is no longer under active development. And we would prefer that teams use more up-to-date libraries, such as ICU. So again, we would detect this as an internationalization issue in code. Now let's look at how we embed these quality checks into our workflows. Our goal here is to be a platform organization that's an ally to product teams to create high-quality global products. When we detect issues in source content, we have a really natural place to display the results inside Atlas. We can display the status where there are issues, and we already have integrations into GitHub during PRs to display GitHub status checks, like when translations are complete. And we can easily display if there's issues there as well. For other types of issues, we're collaborating with the developer experience team to discuss the most effective way to notify product engineers. Our goal here is to have the right balance of offering support versus being a blocker to product development. We don't want to slow teams down, but we do want them to take internationalization issues seriously in the same way that they take security issues seriously and accessibility issues seriously. Back to you, Mike.
So you may have noticed that a number of the issues that we are finding in the code with our static analysis engines are things that AI automatically created for an out-of-the-box experience. So we knew we couldn't use AI to say, tell us what's wrong with this code. And it's saying, oh, there's nothing wrong at all. But we already know from experience that that's incorrect. So the idea is we know teams of other people have worked on this. So doing research found something by, I have to look up an article on source code internationalization, self-healing using artificial intelligence, which was an article I found posted on LinkedIn by Saurabh Kavedekar and Anna Navarro, or Anna Schlegel. It was first published in 2021, where they talked about using AI to look for internationalization issues in the code and then do self-healing, basically provide automated refactoring or PRs for what would be required to fix that code. So looking at that, said this is the way to go. It's basically we need to do the training of the AI to be able to use AI to help fix the code that we have. And so that is the process that we have going forward. So using the projects that we have now for doing the static analysis initially for content, static analysis initially of the code, being able to build up data sets of anti-patterns that then we can compare against what we know as good patterns and be able to use that to train AI engines against the code. Then we can let it loose against the code lines that we have today and then be able to ideally integrate it in to our development process in the future for any new code that comes along. So this will involve the patterns, which is a step that we're working on now, to build up the pre-training data and then going through scanning the repositories, scanning and scanning and scanning. And that isn't exactly automatic. You do the scans, but when you have static analysis, you oftentimes get a lot of basically false positives that come across. So there's going to be an extended period of time to saying, no, we don't, this is okay, this is bad, this is good, this so on. Examples are you're scanning for embedded strings, and you go, oh, embedded strings you shouldn't have in the code, but If they're embedded strings that are going into log files, you go, that's okay. So cases like that you want to go through and then start fine-tuning the scanners that we have to come up with a high confidence set of data to then be able to train the AI against. So there's a scan, train, refine, scan, train, refine, scan, train, refine. And then once that's in place, continue forward with the scanning, integrating it into Atlas so we have reports that are coming back, and then working on what the self-healing looks like. What would the refactored code look like based on the issues that are detected? And that is taking key snippets of the major areas that we're highlighting and saying, based on what's found, what is the solution? And oftentimes the solution, and where static analysis doesn't work, but AI does, the solution requires making changes across multiple files. It's not just one single file where the code is, but it's the code. It's also the external resource files that may deal with changes in configuration, et cetera. And the AI engines that we use, they'll have access across all files in each repo as we go into them. So that'll be greatly increase the ability of what we can detect other than just using static analysis engines. Also, the advantage is that we can infer the usage based on things such as variables in weakly typed languages, as opposed to static analysis engines don't do a good job with that because various construct will come in, you just go, is this an integer or is this a string? Well, based on the variables that come in, we can be able to infer that and increase the confidence of what we get back. And then working again, like Yaniv said, integrating it into our developer experience process. So we feel like, yes, we are going to go forward with AI in training the both positive and negative experiences and the curation. So that's the part of the training that goes in place. And then, as I mentioned, understanding the intent based on the variables that are there. So where are we today? So in the abstract, we said we're presenting on our progress to date with the project. We're actively in the scanning tool development and working on the designs. We're fine-tuning the results that come across that are in place. And so going into next year, we'll be working on the AI, the full-scale AI training based on the data that we discover, and hope that by the end of the year, next year, we should be in a good state where we have AI actually doing high confidence internationalization issue detection, and we'll be well along on the self-healing process that's in place. So I want to give shout out to our organization members and partners and go into any Q&A for the next 5 or 8 minutes. So if you have any questions, there's 2 microphones in the back.
Hello, I'm Nebojša Ćirić from Google.
Yep.
So first one, plug for inflection library. You could use it in some of the cases.
Okay,
Yep.
yes.
So we tried using AI in grammar fixing, and it's fairly good with that. So I'm just thinking of static linters for your translations. You could potentially use AI for finding out if something's wrong with the actual sentence. That might be a good tandem.
So we actually have a project in place today that is doing that, because LLMs are super good at making sure that the grammar that comes out is appropriate or not. So we have developed by a parallel team and our localization team using AI to look at the quality of translated results that come out to be sure that those are high quality. So that's something we do have in place, and we're pulling that in to work on the quality of the English source as well.
So the question, are you planning on having this in open source, or is it going to be in-house, the code detection problems? Because I'm guessing everybody is kind of looking at that.
Well, we'll be looking at how the ultimate project is structured that's in place, but I think a lot of the patterns will be transferable. We have some partners in the industry. We said we'll be more than happy to share the results and our findings, and we have as one of the top pillars for Block is to be an open source first company. So we'll do what we can. It also depends on how many spare people we have on our team to open source it.
Thank you.
Peter.
Peter Constable, Microsoft. We all know the quip about insanity, doing the same thing over and over, but expecting different results. And one thing that in the internationalization sector that we've thought about for a long time is, boy, it would be nice if engineers were better educated about internationalization, right? Eventually, you have to get to a point of saying, yeah, that's not going to happen. So why do we keep expecting the life would be better if only that could happen? And so I look at what you're doing, and I'm thinking, yeah, maybe we can stop saying, boy, if engineers could be better educated about internationalization. Like, is there a future in which you could get to a point where you don't expect the engineer to know how to write that message properly formatted to deal with internationalization or request a date? They just put something in, and you've got something that can do the right thing. One of the aspects of open source, people often think of open source as altruistic, right? Oh, software should be free. I come from a perspective where open source makes sense when it makes engineering economic sense. And I don't think any of our companies are competing on, can we train our engineers to do better internationalization, right? So, building on Neboj's question, this seems like there's a potential opportunity here for a consortium, Unicode consortium project to collaborate together to solve a problem that every software company that is doing, shipping products in more than one language deals with. How do you write your code in a way that is easily localizable and maintainable, right? So it seems like there should be a good opportunity to pursue there in collaboration. So maybe this is something for Bob Jung to consider, on the Unicode board. Is there a potential Unicode project there?
Oh, thank you.
Love that idea.
Hi, I'm Alexei. I actually, previous people who asked questions got my ideas as well. So my only addition to that is actually collaborate not only within Unicode, but also with Anthropic, with Google, with Meta, basically the companies who produce code generation models. And let's ensure that the good quality data is fed into those models, and like the I18n is got right from the code generation place, because more and more of that thing will be created, and it's our goal of educating the model, and probably it's easier than educating all the engineers to write the good I18n quality code.
Thank you.
That's very similar to what we mentioned about reactive versus proactive. So rather than trying to fix everything, it should be better from the beginning. Yeah, agreed.
So there are some AI companies that are looking into this. So codemod.ai, it's a system built up to do automated refactoring. And they have a whole section, codemod.ai/I18n, to help with internationalization or refactoring to add internationalization, but it's specific towards only JavaScript and only towards certain stacks in JavaScript that are in place. And so I look for like these minority languages like Ruby, for instance, and we have to build it all ourselves. But being able to go towards an open source, I think would be definitely a direction to go in that place. I think you were next.
So you show some examples of how you find content and source code issues. Can you give us some details of how you actually do that? Like what tool you use, or when you use it during CI or before?
So there's two different approaches. When we detect issues in source content, that happens as we're ingesting the translation request, which is in our Atlas system.
Which tooling you use? Your own tooling, or?
We're relying under the hood on this open source library called iLibLint.
Okay.
It's more of like the linting approach. So it's if we see an issue in the string as it's coming in, then we can run through each one during the translation request cycle.
And for the source code?
Source code, we're still figuring out where to include that in our production pipeline, but for now it's a separate process that scans an entire repository at once.
And we're building it ourselves, the static tools.
That one we're building internally, yes.
Thank you.
So I'm curious. My name is Markus Scher. I work for Google in Jira's team. I'm interested in the source code scanning that you do. Do you have a sense of how specific that is to the code base that you're training it on, and the types of libraries that are used, and the types of technologies and tech stacks, and the ways people use and write resource bundles and stuff like that, and how well that might work for other code bases that use other technologies, other libraries, other things?
I can start.
So, okay. And this will be the last question, by the way. So.
We are noticing differences between between repositories. So yes, it does relate to the repository. Some teams have approached, like we have some bespoke solutions that we see in certain code bases that don't exist in other code bases. And so it's tempting to mark those as inconsistent or something that we want to replace. But they actually work really well. Like money formatting is a good example. Some teams have spent really a long time on setting this up. It's a little bit different than like a CLDR number formatting, but we want to keep that one. And so there is some difference already that we're seeing between code.
And then what we're doing is we are building internationalization issues up by category. So like a category of embedded strings, and what does that look like in a Java stack? What does that look like in a Ruby stack? What does that look like in a JavaScript stack? Or number formatting, what does that look like in each one of the various stacks? But in the categories, and then building up the engine so we can report consistently on I18n category, no matter what the stack is, and then we'll be reporting back on basically number of issues per 1,000 lines of code, so we can compare apples to apples across the various areas. So you really will have to be our last question.
Okay. Since I was called out by Peter, I wanted to respond.
Thank you, Bob.
I'm Bob. I'm on the board, and I really appreciate Peter's comment. It's something that we have talked about, how we're trying to make our consortium more relevant in the age of AI and LLM, and so these issues have come up. But what I want to say here is that I, as a board member, can push these things, but what I need is for people to put more concrete proposals for us to push, and more importantly, we need volunteers to actually write those proposals and actually start those projects, because the board can't do it. The board can support it, but that's what the appeal I put out to this group and people you know, bring me a proposal and bring me some volunteers.
All right, thank you all.